So when it comes to adsorption, along with colloids, adsorption and a little bit of catalysis is basically going to be in surface chemistry in our scheme of things. So as some of you would know already, uh, out here, we talk about surface absorption. So the accumulation of molecular species at the surface, rather than in the bulk of a solid is termed adsorption. So right away, adsorption is going to be the common name for a surface absorption kind of thing. Absorption is something, where it would go into the bulk or the mass of uh, the absorbent. In this case, it's going to accumulate on the surface. The substance which concentrates or accumulates on the surface is called the adsorbate, and the material in which it goes or adsorption occurs is called adsorbent. Naturally, it's a surface phenomena. Solids in finely divided state having larger surface area are the common absorbent. So more than anything, it's about drawing familiarity with some of these names. Naturally, finely divided state having larger surface area, charcoal, silica gel, alumina gel, clay, colloid. Metals in finely divided state is something we have seen so often. Platinum, palladium for hydrogen in organic chemistry, finely divided nickel, a particular form of nickel which is called Rani nickel, Rani nickel, and there are all going to have more surface area and will act as good adsorbent. So way back when this topic was there in NCRT as well, I would have populated all these examples from NCRT or popular sources. We just want to go past all of it one by one. Now, gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide, containing powdered charcoal, pressure in vessel decreases. This means the gases are getting absorbed. So charcoal is good at absorbing, the popular gases, powdered charcoal, as it so says.
Yes.
Organic dye, methylene blue, when animal charcoal is added, second filtrate is colorless. This would take care of some, routine theoretical questions where a dye methylene blue and, the filtrate is colorless. So basically the dye is getting absorbed into the charcoal. Presence of silica gel is going to keep the medium or the atmosphere free of moisture. So water molecules will get absorbed, but silica gel, uh, the reverse of adsorption is called desorption. So if this is something getting accumulated over the surface, desorption naturally would be the reverse of it. Desorption would be the surface, releasing the adsorbent. Adsorption of gases on metal surface is also called occlusion. It's mostly popular for hydrogen on, platinum, palladium. That's called occluded hydrogen. It's going to stay in the atomic form and is naturally going to be much more reactive. Now, the substance is concentrating only on the surface and not in bulk is something I've already explained, the difference between adsorption and absorption. In absorption, the substance is uniformly distributed toward the bulk of solid. So, again, a very nice little example. Chalk dipped in ink and the surface retains the color of the ink due to adsorption of colored molecules, while the solvent of ink goes deeper into chalk stick. And, there's like more like a story. Chalk when dipped into ink, the outer layer of the chalk surface, would absorb the color dye. And, when you break it, it would be like white from inside. So small little stories, we'll want to relate to. Water vapor से absorb by silica gel, absorb by anhydrous calcium chloride. सिलिका जेल से जो हो रहा है वो एब्जॉर्प्शन हो रहा है और कैल्शियम क्लोराइड में जो हो रहा है वो अब्जॉर्प्शन हो रहा है. So most of the dehydrating agents, when they form CaCl2.5H2O, it's about absorbing water altogether, whereas the silica gel, would absorb it only on the surface. Both adsorption and absorption can occur simultaneously. So there's a common name, which is called sorption. Now, there is a small bit of story, behind any surface phenomena, which I also spoke about at times. So, what's the difference between particle at the surface and the particles which are in the bulk of any solid? When it comes to a particles in the bulk of any solid, I talk about a particle out here, a particle out here. So, this particle out here is going to be surrounded by similar particles around it. So, if I talk about these particles, even forces of attraction, would be evened out. because it's surrounded by even number of by uniform distribution of particles around it. यहाँ पर कोई force भी होगा ना इस particular sphere के ऊपर, that force is going to evening out. I hope you're understanding me. This is true
हाँ,
for
वो
any
सब
particle.
कैंसिल हो जाएगा वो उसका कंपोनेंट।
This is true for any surface phenomena. ये अगर एक particular particle का बात करें जो volume के अंदर में, तो उसके चारों तरफ uniform particles है, and the net force over any particle in the bulk because of particles around it, the net force around any particle in the surface would be zero. Whereas if you talk about particle at the surface, this is responsible for our surface phenomena. इसके नीचे में जो पार्टिकल है, ये नीचे में तो इसको खींच रहा है. See, interaction between particles is universal. नीचे में तो खींच रहा है, ऊपर में कुछ नहीं है. So you can say that there is a net inward pull. There is a net inward pull, and this net inward pull, this residual inward pull, is responsible behind the surface particles being a little more agile, restless, and willing कि भाई इसके ऊपर में भी कुछ पार्टिकल आ जाए. यहाँ पे अगर कोई फ्लूइड आके एक्यूमुलेट हो जाए, तो ये फ्लूइड के आने से नेचुरली ये जो फोर्स होगा, ये जो इनवर्ड पुल होगा, वो टू सम एक्सटेंट विल बी न्यूट्रलाइज्ड और काउंटरएक्टेड और रिलीज. Now this is what I have explained, that inside the adsorbent all forces between particles are balanced, but on the surface particles are not surrounded by atoms of their kind on all sides. They possess an unbalanced residual force which are responsible for adsorption or any surface phenomenon. And naturally this is going to increase with increase of surface area because of the surface particles which are responsible, for exhibiting these phenomena. The mechanism or thermodynamics of adsorption is again very plain, straightforward. During adsorption, decrease in residual forces will decrease in surface energy. Now, when I say decrease in surface energy, it's about, as I told you, when you have particles accumulating on the surface. Suppose, this is a net inward pull over these particles. अब यहाँ पे कोई गैस का मॉलिक्यूल, लिक्विड का मॉलिक्यूल आके जमा हो जाता है, तो यहाँ पर भी थोड़ा फोर्स आ जाएगा जो इसको इम्बैलेंस करेगा. इसी को बोलते हैं कि जो नेट इनवर्ड पुल जो है, जो सरफेस एनर्जी है, ये रिलीज होता है. और अगर ये सरफेस एनर्जी रिलीज होता है, इट्स ऑलवेज गोइंग टू बी dissipating as heat, and the process will be exothermic. So delta H adsorption, heat of adsorption, you can say, is negative. It's a exothermic process. Now, because the freedom of molecules, is going to get decreased. A fluid था पहले, they could have free movement, and now because it has come and accumulated over a metal surface, naturally the freedom has been curbed, which will result in decrease in entropy. तो एक हिसाब से entropy और enthalpy दोनों ही negative है. Enthalpy entropy दोनों ही negative है. Enthalpy is the heat exchange at constant pressure, and it's an exothermic process. It's an exothermic process जहाँ पे the entropy of the fluid molecules will be decreased. The freedom will be decreased. Now, if I go by this popular Gibbs equation, delta G is equal to delta H minus P delta S, right away delta S negative will mean minus P delta S is positive. So minus P delta S is positive, and you want delta G to be negative for the process to be feasible. So because delta S is negative and minus P delta S is positive, for delta G to be negative, the magnitude of delta H, the negative magnitude of delta H should be more than the value of P delta S. So naturally, to begin with, for the process to happen, delta H has to be sufficiently negative for the particle to carry on, for the surface to carry on absorbing fluid particles, so that, with a delta H value too big, too negative, is to surpass the positive value of P delta S, minus P delta S, and delta G to be negative. Any process would come to an equilibrium. And in this case, the equilibrium is when adsorption and desorption will start happening at the same rate. And as more surface particles are covered, delta H will become less and less. It will become less and less negative. It will become less exothermic. At one point, when the two values are equal, delta G will be equal to 0. Delta G is equal to 0 will be the point of equilibrium, dynamic equilibrium. In this category, the most common question, the routine question at one point of time, popular with the board examiners, was the type of adsorption, which is physical adsorption, when the forces are purely physical in nature, irrespective of the chemical nature of the adsorbent and the adsorbent. And a chemical adsorption is going to be some likeliness for a given adsorbent, and that's going to be involving some kind of a bonding, or paired, unpaired electrons, available orbitals. So a bit of a chemical interaction, we'll call it chemical adsorption. If it's purely physical in nature, you call it physical adsorption. Another way of writing the same is physiopsin and chemiopsin. Now these are points which are populated yet again from popular sources and nothing peculiar. It's because of purely physical forces which are intermolecular. Van der Waals forces, they are not specific, are reversible in nature, depend on the nature of the gas. A more easily liquefiable gas. You remember Van der Waals forces and all? A more easily liquefiable gas will be absorbed more readily. Whereas this is due to some chemical interaction, some chemical bond formation. So this will be specific, particular surface will be particularly, more absorbing for a given fluid. Could be irreversible in nature, depends on the nature of the gas which reacts with adsorbent, so chemisorption. So for platinum, palladium, nickel, hydrogen is a preferred, gas to be absorbed on the surface. So as I told you, this would be like very routine stuff. Heat of adsorption is low because it's more like a physical process, and it's high because it's more like, you don't need to mug up this value. It's high because it's more like a chemical change. Low temperature is favorable right away, because an exothermic process, and from the days of the Chatelier's principle, delta H negative exothermic is going to be better at lower temperature. Now, because there is no activation energy involved, there is no fund of crossing an energy barrier, and right away you will want to stick to low temperature. Whereas in this case, because there is going to be some activation energy involved, a little bit of temperature is required to, more molecules to surpass that energy barrier for the process to get started. Initially, you will want a little bit of temperature, but then because the nature is exothermic, eventually, you will want the temperature to be lowered. Initially increases with increase in temperature, but as I told you, after a while, low temperature will favor any exothermic. Both will increase with surface area. This is naturally going to be a common parameter, both surface phenomena. Both will require high pressure. High pressure would help in adsorption, but decrease in pressure causing desorption here is about this being reversible, and decrease in pressure not causing. So this is being irreversible. Like a physical process, it could be multi-layered, and this is unimolecular. Like once the valencies are satisfied, that's far and open. So these are some key points you'll want to know about physiopsin and chemisorption. Last but not the least is one particular isotherm, which is going to explain how the amount of the fluid adsorbed at a given temperature would vary with pressure. Isotherm because it's going to be measured at constant temperature. It's about adsorption with pressure. Naturally, there are two adsorption isotherms. One is Friedrich and another was Langmuir, but Langmuir is no longer in the syllabus of any exam. So I just limited to Friedrich. Friedrich in 1909 gave this particular result. X by m is equal to xk into p to the power 1 by n. Where you just want to figure it out that x is the mass of gas adsorbed on a mass m of the adsorbent. So basically x by m is mass of gas adsorbed per unit mass of the adsorbent. So basically x by m is the extent of adsorption, or how effective, it has been. Now pressure is what we are plotting it against. Constant temperature, so they're called isotherms. K and N are going to be constants depending upon the nature of the adsorbent and the gas. I write it again. X by m is equal to k into p to the power 1 by n. Log x by m is equal to log k plus 1 by n log p. यहाँ पे लिखा हुआ है n is greater than 1, so this ratio is always less than 1 or equal to 1 at most. Taking log on both sides. It's a very popular question at times. Plotting log x by m versus log p. Now this is like mx is equal to y plus c. This is mx plus y plus c. This is along the y-axis. This is along the x-axis. The c is the y-intercept log k. The slope 1 by n tan theta. The slope would be 1 by n. So around this time, I think you would have either taken a printout of this. Don't waste time in copying it down. And in this basic discussion video, If you have any point, any doubt, you can raise it. Otherwise, these are some very popular questions. Naturally, these are different isotherms, and with temperature increasing, H by M decreasing is again about the nature of the process, which is exothermic, for which lower temperature is desired. So they give you temperature T1, T2, T3, and all you need to know is, in this case, T1 is more than T2, more than T3. A lower temperature, would make it. We want it to be more if the temperature is less. So naturally, I hope I'm being understood. Somebody will want to respond with a yes or no, and we'll want to move on.
Yes, sir.
It explaining adsorption in an approximate manner. 1 by n can be a value between 0 and 1. This is very basic routine stuff. When 1 by n is equal to 1, h by m is equal to kT. So it's directly, varying with pressure. When 1 by n is equal to 0, this is going to become a constant, independent of pressure. But isotherms always approaching saturation at high pressure is where this isotherm has its limitations. I told you there is another isotherm called Langmuir isotherm, which is no longer in the syllabus. अगर मेरे को इससे कुछ क्वेश्चन मिलेगा ना लैंग्वेज से तो मैं वो भी 15 मिनट में 3 दिन पढ़ा दूंगा. Otherwise, we'll want to keep it limited to x by m is equal to k into p1 to the power 1 by n for gaseous, and x by m is equal to k into c to the power 1 by n when it's a solution with a concentration C in molarity. When solution of acetic acid is taken with charcoal, part of acid is adsorbed and its concentration decreases. You can check it with litmus solution with this charcoal. Magnesium hydroxide becoming blue in presence of magnesium reagent. ये सब ना पुराना एनसीईआरटी में लिखा हुआ कुछ पॉपुलर फैक्ट्स है. एक बार देख करके जाना. Application of adsorption is how we'll want to end this topic. You would have found certain small balls or packets, in different medicines or some food items, वो obviously वो absorb करता है, air absorb करता है, moisture, basically moisture absorb करने के लिए होता है. I hope I'm being understood. गैस मास्क में एक्टिवेटेड चार्ज में पॉइजनस गैस एब्जॉर्ब कर सकता है. कार्बन डाइऑक्साइड, सल्फर डाइऑक्साइड, अमोनिया, क्लोरीन सभी तो पॉइजनस है. एब्जॉर्ब करता है, ह्यूमिडिटी कंट्रोल करता है, कलरिंग मटेरियल डाई को एब्जॉर्ब करता है, हेटेरोजेनस कैटालिसिस. इसका मैं एक नोट्स थोड़ा सा कैटालिसिस का भेज दूंगा. Separation of inert gases, there is also an interesting fact. The discovery of inert gases, and their separation owes a lot to adsorption. Curing diseases by some drugs absorbing germs on their surface, and again, there's going to be such an important factor. I hope force flotation is something you would have known by now. It was there in my video on metallurgy. In the next couple of days, I'm going to discuss more methods of extracting more metal, where force flotation, is a method specialized for sulfides. You remember sulfides, and you have fine oil and some stabilizers, which will help in the concentration or dressing of sulfide ores, and that's also surface property. That's surface adsorption, where the oil and the corresponding froth attach itself to the froth sulfur particles only, and the impurity, which is called the gangue, or matrix, would be wetted by water and will settle down. It's an interesting aspect of the extraction of, the metallurgy of sulfides, galena, zinc sulfide. We'll take those topics in times to come. This is a little bit we wanted to know about adsorption, where if you ask me questions from, this segment, and then, the difference between physioption and chemisorption, and then, the fact that अगर यहाँ पर तुमको थोड़ा टेम्परेचर चाहिए और उसके बाद टेम्परेचर के साथ में काम होगा, तो टेम्परेचर के साथ में अगर कुछ वेरी करता है, देखो प्रेशर के साथ में वेरी कर रहा था, कांस्टेंट टेम्परेचर था तो आइसोथर्म था. अगर टेम्परेचर के साथ में वेरी करता है, तो उसको हम लोग आइसो बार बोले. प्रेशर कांस्टेंट है, तो फिजिकल एड्जॉर्प्शन में ये सिंपल ऐसा रहेगा, प्रेशर के साथ में, टेम्परेचर के साथ में. ये डिक्रीज करेगा, और सेम इस ऑप्शन में ये पहले इंक्रीज करेगा फिर डिक्रीज करेगा विद प्रेशर एडजॉर्प्शन। एक बार ये भी मान लो, ठीक है। तो यहाँ पे राइट अवे यू वांट टेम्परेचर टू बी लो, लो टेम्परेचर, टेम्परेचर बढ़ेगा एक बार घटेगा, यहाँ पहले बढ़ेगा, उसके बाद एक पॉइंट पर वापस इट विल स्टार्ट कमिंग डाउन। And a little bit about the thermodynamics which I've told you, the process having both delta S negative, delta S negative. A few informations and chances are a question on this topic would be like a free scoring opportunity. I'm going to say notes on catalysis at the next opportunity, maybe within the next 1 hour or so, and questions on surface chemistry, which I'll be looking forward to discuss with you tomorrow. This much for the time being. Stay happy, stay healthy. Thanks for joining the class. बाकी बात WhatsApp पे करते हैं. Take care, बच्चे लोग. Bye bye.